Hello, this is Mr. Wyrick here with you for Lesson 1-7, three-dimensional objects, three-dimensional figures. Now, there's quite a few terms up here that you will define in your notes, and there's a chart that you'll need to make sure that you copy into your notes for today's lesson. Make sure you're keeping track of those things. I'll do a check on them probably when we reach the end of Chapter 1. Now, the main thing that we're working with right now is just kind of identifying them. So you have a three-dimensional solid. You can tell by the way that it's drawn on the paper that it's a three-dimensional solid. So it's either going to be a polyhedron kind of shape or a non-polyhedron. It'll be a polyhedron if it has edges. So if I draw this pentagon here, and I draw another pentagon up here, and then I connect those edge to edge using kind of a dotted line to tell you that you won't be able to see that as an edge. Each one of these intersections, of course, is a vertex. And then we have the edges along the sides. This is a prism. It's a polyhedron. It's a pentagonal prism. That means it has a pentagon at the top and the bottom, and it has the sides extending down. It's not a polyhedron if it has smooth or rounded sides. So a cylinder that would be like a soda can or something like that, that doesn't count as a polyhedron. A cone, not a pyramid, but a cone with a circle on the bottom coming up to a single point, and a sphere, a ball, those aren't polyhedrons. We have different things to deal with the edges of those. When you are dealing with those, you can have some regular polyhedrons. You're most familiar with a cube. It's exactly the same on every single edge. There's only specific ones of those. Go ahead and check the book. Make sure you understand which one of those can be regular polyhedrons. They're also known as the Platonic solids because Plato did a lot of work with those. You can tell we've been doing this stuff for a really long time. The next thing that you need to worry about with these, and what you'll probably be doing most of the calculation once you finish just identifying the shape, is going to be surface area and volume. There's a chart in your book that's labeled how to find the surface area and volume. You should copy those formulas down. Probably you need to do your best to memorize those, but if you can't memorize them, keep that cheat sheet handy. It'll probably be on the formula chart for the test too. But I feel like it's a giant waste of time if you have to look those up every single time. You should start remembering, okay, this is a sphere. If I'm going to calculate the volume of the sphere, it's 4/3 pi radius cubed. You may only have to remember it for this year. You may be extending your knowledge beyond that. Definitely, I would say, for this year especially, try to get those memorized. Do your best. The surface area, if you're unfamiliar with surface area, is going to be, you calculate each one of these rectangles around this prism, and then you're going to calculate the area of the top and bottom. The surface area is what it would take to like wrap the whole thing up like a Christmas present. You may also see in here, and I'm not sure if it's in this lesson, but just be aware of it, the lateral surface area would be just a label. So if I'm going to find the lateral surface area of this pentagonal prism, I'm only going to find these rectangular edges. I'm not going to worry about the top or the bottom. Now, when you're dealing with pyramids, when you're dealing with cones, there's some special properties there as far as lateral goes. You may have to use what's called the slant height, and the slant height is always indicated with a cursive lowercase l. So start remembering the fact that a cursive lowercase l is always going to mean your slant height. When you come in for this lesson, I will be back from out of town from my trip, so you'll be able to look into this. We'll be doing some surface area, some volume of three-dimensional figures, and some identifying of everyday objects that are three-dimensional figures. We'll see you then.